So today we're going to look at writing linear equations. More specifically, we're going to use the information that we learned Wednesday about parallel and perpendicular lines, and we're going to actually write equations for parallel and perpendicular lines today. So just a reminder that slopes of parallel lines are equal and slopes of perpendicular lines are negative reciprocals. And so here we have a line that has an original slope, M1 is at 2/5. And so if I was going to create a line parallel to that, my M2 would be 2/5. But if I were to create a line perpendicular to that, then my M2 would be, first I flip it, then I negate it. So -5/2. Okay, so that's what we went over on Wednesday. Is there any questions still about the slopes of parallel and perpendicular lines? No? Okay, so today we're going to write linear equations for these parallel and perpendicular lines. So recall the unique line postulate, which we got in Unit 1, which state that through any 2 points there exists one and only one line. And so today we're going to create an equation which will represent that one line. So there are two ways to write the equation for unique line: point slope form and slope intercept form. And we're going to work with both of these today. So basically, the first thing I'm going to do is show you how to write an equation for any line in general. So the way that you create an equation for any line in general, the first thing you want to do is find the slope of those 2 points. So we're going to use our slope formula, y2 minus y1 over x2 minus x1. So 6, -1, -3, 2. This is my x1 and my y1. This is my x2 and my y2, and that's what I'm plugging in there. And so now I'm going to find the slope. That gives me 9 over -3. 9 divided by -3 is -3. I think it's a positive 3. Okay, I'm using my calculator. Okay. And so is 3. Okay, -3. So -3 times -3 gives me a positive 9. So -3. So my slope is -3. So that will represent, will represent my M. So now I'm going to create an equation using that information. So the way that I do it in point slope form is basically you're going to take your y1, your x1, and your m and plug that all in. So y minus my y1 was -3 is equal to my m, we just solved it, is -3. X minus my x1, which was 2. And then I actually just go ahead and solve for this. So this changes to a positive 3 equal x minus 2. I'm going to go ahead and distribute that. And then move my 3 over. So y equals -3x plus 3. And so that is my resulting equation. And that equation will represent the line that passes through 2 and -3 and -1 and 6. And I went ahead and distributed that so you could see it. Okay. My slope intercept form, on the other hand, the way that I do it is I keep my y what it is. I insert my m, which I discovered is -3. X stays the same. And I need to look for my b because I'm not given any information about my b. So the way I identify what my b is I'm going to plug in an x and a y. So I'll use the 2 and -3. And then I solve, and that will give me my b. And so that equals -6 plus b. Put this over. B is equal to 3. And now that I know b is equal to 3, I'm just going to plug that in. So y equals, what is my m? -3x. And then my b now is 3. So I put 3 in. And so that gives me my resulting equation. And what you'll notice is I get the same equation both ways. So it really just depends on whatever your preference is to solve. But that's how you solve it. You're going to input your slope in both of them, and and you're going to input your x1 and your y1 in this one. And this one you can choose any x and y. It could have been the -1 and 6. But I just use my x1 and my y1, and that allows me to solve for b here. And then here I'm just distributing until I simplify it. Okay? Any questions about how I solved for the equation of the line that passes through these 2 points? Questions? No? Okay, so now we're going to actually get into, let's look at this example problem. This says writing an equation in slope-intercept form. Determine the equation for the given line in slope-intercept form. So there are actually 2 ways that I can go ahead and solve this problem. The first thing I always want to do is identify my slope, because that will give me my basis for everything. So there's 2 ways that I can do that. The first one, again, like we discussed, I can do rise over run. So 1, 2, 3. 1, 2, 3, 4, 5. This is a -3, 5. So I'm going to get -3 over 5 as my slope. So I can solve it like that. Or I can do my slope form. M is equal to y2 minus y1, x2 minus x1. So I could do -5 and -4, and 0 and 1. Those are 2 points that I have here. Just for reference, this is 0 and -1. And this is 5. And this is 5 and -4. Okay. And when I do that, I will see that this is equal to, hold on 1 second. This is a -1. -1. Okay. And then that gives me -3 over 5. Okay. And so you'll see I get the same slope. The reason I can use rise over run here is because I technically am going by units of 1. But whatever your preference is to find your slope. And then this question's pretty easy because you're looking for which of these has the slope of -3 over 5. And the only answer choice that has that slope is D. Right? You have -3 over 5 as your slope. However, if you did in fact want to solve for the actual equation, all you would have to do is use your slope-intercept form. So I'm looking for my B. I need to know my B. So I'm just going to plug in 1y. In this instance, I'll plug in the 0 and -1. And this would allow me to solve for my B if I did in fact have to. If I had 2 answer choices that had the same slope, this would allow me to solve for my accurate B. And so there you'll see that B, -1 equals B. So B is equal to -1, and so now your new equation is x minus 1, which is what your answer choice D is. Okay, any questions here? So you want to pick 2 points on that line, identify your slope, and then identify your B by plugging it into slope-intercept form. Okay? Now we're actually going to get into writing equations for parallel and perpendicular lines. So writing an equation of parallel lines from the graph. So it says determine the equation of the line that is parallel to the given line and passes through the given points. So the first thing you want to do is, because these things are parallel, what you want to do is you want to find your M1 and your M2 will be equal to it. So the slope of your given line, again, you can do rise over run because you're going by ones, or you can put it into your slope intercept form. I'll just go ahead and do rise over run. 2, 3, 4. So 4 upward. 1, 2, 3. So 4 over 3. So that is my slope. So I know that my slopes have to be equal. So my slope of the line that I'm looking to, it also is going to be 4 over 3. Again, I can put this into my slope formula, whatever your preference is. Now that I have this, what I'm going to do is I'm going to find the equation for this given line. the way that I'm going to do this is I'm going to identify what points even are these of this point that I'm looking for, that line for. And this is at 4 and 4. Okay, so now that I know that, I'm going to use my point slope form, which is y minus y1 equals mx minus x1. And that will give me the equation of this line which passes through this point that is also parallel to my orange line. So y minus, and my y1 is going to be the point that I need to identify. So my 4, 4. I already have my m, which is 4 over 3, x minus my x1 in that instance is also 4. And this is where I solve to find my equation of my line, which is parallel to my orange line. So distribute this over 3x minus 16 over 3 equals y minus 4. Now I'm going to move this over. So plus 4, y equals 4 over 3x minus 4 over 3. And so that is my end equation. And that is the equation which represents my line that if I were to create it, that would pass through this point. So if I were to create a line which is parallel to my orange line, the equation of this line would be that equation that we just solved for. Any questions? No? Okay. So that is if we are given a graph. If we're not, we might just be given a problem that looks like this, and we're actually told what that point is. The other one, we had to identify what the coordinate of that missing point was. This one, we're given it. And so it says, a given line has the equation, and we're given the equation of our given line. What is the equation of the line that would be parallel to that given line and pass through these points? And so parallel means that the slope's going to be the same, but I need to find my slope of my given line. So I'm going to rearrange that into slope form. And the way I'm going to do that is just I need to have my y on one side. So negative 4y divided by 4, negative 4. So y is equal to 3/4 x minus 4. So that is my equation of my given line. But what that tells me is that my slope of my given line is 3 over 4. And my line, which is perpendicular, has to have the same slope. Or my line, which is parallel, has to have the same slope. So I'm going to create an equation for a line which is parallel to my given line and has this point. So now that I have my slope, I'm going to put that into point slope form. My slope is, well, I could just do it. For my equation, my x1 is negative 2. Or for my equation for the point that I am given, 3 over 4 will be my slope because it needs to be the same in order for it to be parallel. X minus, and then my x1 will be 4. And then that's what I'm solving. So I'm going to simplify that. I'm going to go ahead and distribute, which could mean and then I'm going to go ahead and move my plus 2. So that's y equals 3/4 x minus 5. So that is my equation of my line, which is parallel to my given line, but contains the points 4 and negative 2. And what you'll notice is they both have the same slope. Okay. Any questions about how to find the slope of parallel lines? Parallel lines? No? Okay, now we're going to find the slope of perpendicular lines. This says, what is the equation of slope-intercept form of a line that is perpendicular to the given line and passes through the given point? So basically, we'll do the same thing, but what we need to do is identify the slope and then find the negative reciprocal And the negative reciprocal is the slope we're going to put into our point slope form. And so here, we're going by twos. So 2, 4. And this is 1. So 4 over 1. Again, I can put this into my slope formula and solve that way as well if I wanted to. But here I'm going by twos. It's pretty simple to count. This is 2, this is 2, and then that's half of 2, so that's 1. So 4, 1 is my slope of my given line. This is my M1. So I need to find my M2, and that's which is perpendicular, so I need the negative reciprocal. So I'm going to flip it and then negate it. So now the slope of my line perpendicular has to be negative 1 over 4, because that has to be the negative reciprocal. So that is what I'm going to plug into my slope intercept form. And I need this point because I need the line for the line that passes through this point. And so that's what I'm plugging in. So y minus negative 4 equals my m is negative 1 over 4 x minus, my x in this instance is 8. So I'm finding the equation for my line, which is perpendicular to my orange line, but passes through the points 8 and a negative 4. And now I just simplify. Distribute. Isolate my y. Y is equal to negative 1 over 4x minus 2. And so that is my equation for a line that if I were to draw it here, it would be the equation of this line right here. The line which is perpendicular to my given line. So it intersects at 90 degrees. Okay, and what we'll notice is that the slope for the line that I just created is the negative reciprocal of my original line, which was 4 over 1. Okay, questions, concerns? So basically, you're doing the same thing as solving for parallel lines, but because it's perpendicular, you need to find the negative reciprocal slope. You're not just going to plug in the slope that you're given. Okay. So let's kind of put this together. This problem asks us to identify an equation of a line which is parallel and a line which is perpendicular to my given line. So what is the equation in slope-intercept form of the line that is parallel to the line y minus 3 equals 2 over 5 x minus 1 and passes through the points negative 2 and 3? What is the equation of the line that is perpendicular to this given line and passes through that same given point? So we are given an equation for our given line. And so I want to identify my slope out of that. So I'll do it quickly here. I need to get it into slope-intercept form. Oh. What is happening? Why is it doing that? Okay, there. So I'm just gonna go ahead and solve. So I need to distribute this. And then I'm gonna add 3 to both sides. So y equals 2 over 5x plus 13 over 5. So that is my equation of my given line. Okay, so basically I just rearranged it to find the slope of my given line. So I'll put that there. Okay, so now I'm going to look for the line which is parallel. What is happening? Why is it doing that? Sorry guys, technical. Okay, parallel and perpendicular. So I need to find both equations. And so if it's going to be parallel, it's going to have the same slope. So y minus 3, which is my y1, equals m, which is going to be the same m, x minus negative 2. And I'm getting 3 and negative 2 from here. okay? And so I can solve for that. For my perpendicular, I need the negative reciprocal. So same thing, I'm using the same point, but now I need the negative reciprocal, which is negative 5 over 2. Flip the fraction and then negate it, x minus negative 2. And then, so that's what I'm simplifying and solving for. What are the equations going to be for these lines? Again, I distribute here. So plus 3, y equals 2 over 5x plus 19 over 5. This one, same thing. Do this, distribute. Y minus 3 equals minus 5 plus 3 plus 3. Y equals negative 5, 2x minus 2. And so there I have my equation of my perpendicular line, and here I have my equation of my line that is parallel. Okay. Any questions still about how to find the slope or the equation for a line which is parallel and a line which is perpendicular? Okay. So today we were able to write an equation of a line which requires, whenever we write an equation for a line, it requires the slope of the line and the points on the line. Parallel lines have equal slopes and the y-intercept may be different. Perpendicular lines have slopes which are negative reciprocals, and then the y-intercepts are sometimes different. Okay, any questions? Okay, if there's no other questions, you guys may log off and I will see you guys on Monday. Bye guys.